Chapter 15. Conditional statements. Conditional statements run a chunk of code only when a certain condition is met. Conditional statements follow the if-then format, if this, then that, and they allow programs to be more flexible and powerful because they can change depending on different conditions. For example, if you touch the enemy, then your character dies. If you cross the finish line first, then you win. If you score a goal, then your score increases by 1 point. Here's what a basic conditional statement looks like. If a specific thing happens, then this other thing will happen. Here's what a conditional statement could look like in a quiz game. If the player gives the correct answer, its condition, then the player earns 100 points, its consequence action. An if-then statement can be shown with a flowchart. For example, in a quiz game, where a correct answer earns the player 100 points, a basic conditional statement might look like this. You can have a different action happen if your condition is false. To do that, use else and then describe the different action. If a specific thing happens, then this other thing will happen, else a different thing will happen. Here's what a conditional statement with an else consequence could look like in a quiz game. If the player gives the correct answer, then the player earns 100 points, else the player loses 50 points. An if-then else statement can also be shown with a flowchart. For example, you can combine multiple conditional statements to create even more consequences. To do that, use else if in an if statement. Every else if added within a statement adds another action or consequence that could happen. For example, here's how you can use an else if to get 3 consequences, 3 different actions to happen in a conditional statement. If a specific thing happens, this other thing will happen. Else if another thing happens, a different thing will happen. Else yet another thing will happen. Here's what an if statement with an else if consequence and an else consequence looks like when calculating the number of points a player should get depending on the number of quiz questions they get correct. If a player answers 10 questions correctly, player is awarded 100 points. Else if player answers 5 or more questions correctly, player is awarded 50 points. Else player is awarded 10 points. The flowchart will look like this. Comparison operators. Comparison operators, symbols used when comparing values, are used in programming to form Boolean expressions. An operator greater than is greater than in description, less than is less than, greater than equal is greater than or equal to, less than equal is less than or equal to, equal is equal to, exclamation mark equal is not equal to. Put a value on either side of a comparison operator to make a Boolean expression. For example, 10 greater than 5 is true, 10 less than equal 5 is false, 10 less than 5 is false, 5 equal is true, where equal means equal to, just like equal in math. 5 greater than equal 5 is true, 10 not equal 5 is true. Comparison operators can be used in flowcharts. This flowchart shows that if 10 is greater than 5, you will say yay, else you will say boo. You will say yay because 10 greater than 5 is true. You can use the equal operator to compare 2 values. For example, you could see if a game is over or not based on the player reaching a score of 10 like this. You could also use a Boolean variable by itself. For example, in a race game, you could have a variable called boost. The value of the variable is set to true if the player earns a speed boost. The program uses a conditional statement to check if boost is true, the player has earned a boost. If so, then the program should increase the player's speed. Compound conditionals. To check if multiple conditions are true in one conditional statement, You could combine Boolean expressions within a single conditional statement. Compound conditionals are conditionals that combine two or more Boolean expressions. Logical operators are used to combine the expressions. The most common logical operators are AND, OR, and NOT. And statements are true when both conditions are true. True and true is true. For example, if a player finishes a race and if they finish faster than anyone else, they are the first place winner. But if one or both of the conditions is false, then the AND statement is false. True and false is false. False and false is false. For example, a game player sets a new speed run record only if they beat the game and finish in less time than their current record. If the player just finishes the game but doesn't do it in less time or doesn't finish the game at all, if both conditions are not met, then the player does not set a new record. The OR statement is true if at least one of the conditions is true. False or true is true. True or true is true. False or false is false. For example, in a ball game, if the player hits the right wall or if they hit the left wall, then they lose and the game ends. If either condition of hitting either wall is met, then the consequence losing becomes true. The NOT statement doesn't compare two conditions. Instead, it reverses the value from true to false and false to true. Not false is true, not true is false. Not switches the expression to its opposite. For example, in a race game, we could have a conditional that says, if game over is not true, then play background music. In other words, play music as long as the game is still going. Nested conditionals. A nested conditional is one conditional inside of another conditional. For example, in a virtual pet game, you could nest conditionals to determine the mood of the pet based on different conditions like hunger or tiredness. If the virtual pet is not awake, show the mood as asleep. If the pet is awake and if the pet's hunger is below 50%, then show a happy mood, as show a hungry mood. So if the pet is awake and its hunger level is at 75%, then its mood will be hungry. The flowchart looks like this.